So in this video, we want to take a little bit of time to talk about some things that appear pretty frequently within trigonometry problems, and those things are known as angles of elevation and angles of depression. So if you're working on a problem and it's a story problem, you might have the angle of depression or the angle of elevation described for you within the problem, but then it's on you to know how that fits into a diagram. So you're going to have to draw the diagram and figure out where to put the appropriate angles from the words that you're reading. So if you think about this situation, what we have is we have two horizontals. We have the horizontal path that this plane is flying in, and then we have the horizontal path between this person's eye level. So both of these types of angles that we're about to talk about are measured from horizontals. If we're measuring up from a horizontal, that's known as an angle of elevation. So the angle that this person has to have their eyes at above their straight horizontal eye level is called the angle of elevation because that angle measures up from a horizontal. And then an angle of depression is going to measure downward from a horizontal. So the angle that connects the plane to this person's eye level is measured down from the path of the plane, and that's why it's referred to as an angle of depression. So an angle of elevation always measures upward from a horizontal, an angle of depression always measures downward from a horizontal. So the example that we're going to check out here is going to involve measuring the height of a tree. So we've got a person who is 6 feet tall. They're going to measure the height of a tree in their yard. This is called a hypsometer. So this device here is able to measure several things. That you look through this end of the device, and what you do is this is going to point a laser to whatever you place this on, and it's going to measure several things for you. It's going to measure the distance from the device to what you point the laser on, but then it's also going to measure the angle of elevation if you're pointing it upward, or the angle of depression if you're pointing it downward. So if you read on a little further within this problem, this hypsometer is going to be used to measure the distance and angle of elevation from the top of the person's head to the top branches of the tree. So this is pointed up at the top branches of the tree. The distance measures 80 feet, and the angle of elevation measures 37 degrees. So if we wanted to draw a diagram here, we're going to have the tree right here, measuring to the top branches from this person's eye level is going to be 80 feet. And then the angle of elevation to point the laser at the top branches of the tree is going to be 37 degrees. So this is an angle of elevation, right? We are measuring upward from the horizontal for that angle. So that kind of tells us, yeah, we've established everything properly here. So how are we going to be able to determine what the height of the tree is? So you see I've already labeled that with an X, right? So whatever you're looking for, just toss a variable on there. If you want to use a different variable, you obviously can. So you're going to have to try to determine how the side that you know and the side that you want to know are related to this angle that you know. So I've highlighted three things: the angle, and then the side that we know, and the side that we want to know. The right triangle here, excuse me, the right angle here just confirms for us that we are able to use right triangle trigonometry. We're able to use sine, cosine, and tangent ratios within this situation. So if you think about how this 80 is related to the 37, is it the opposite leg, the adjacent leg, or the hypotenuse of the triangle? Well, that's the longest side of the triangle. That is the side across from the right angle. So this is definitely the hypotenuse. And how about this side that's labeled X? Well, it is not next to or along the 37-degree angle. It is on the other side of the triangle. So this is opposite of the 37-degree angle. This is the hypotenuse. Think about sine, cosine, and tangent ratios. If you've used the SOHCAHTOA shortcut, we have opposite that we want and hypotenuse given to us. O and H are part of that first syllable, the SOH portion of SOHCAHTOA. So I'm using the sine ratio, and it's always sine of the angle that you were dealing with. So in this case, that's 37 degrees. That has to equal the opposite side, which is X, divided by the hypotenuse, which is 80. So you'll notice I have a times 80 on both sides, and that's because I'm already going through the process of solving this for the variable X. So if I'm going to isolate the x, I have to undo this division by 80. So I'll multiply both sides of my equation by 80. What I can do is I can then type 80 times sine of 37 degrees into the calculator, and that tells me that side x is about 48.1 feet. Just pay attention to your teacher, your professor, your problem that you're working on to try to figure out how you're supposed to round that. I just went to the nearest tenth in this case. Easy thing to do in problems like the one we're working on right now is to, once you find the variable, assume that you're done. It's hopefully pretty obvious why we're not quite done here. We weren't measuring from the ground. We were measuring from the top of someone's head who's 6 feet tall. So the side of the triangle is 48.1 feet, but that is not the height of the tree, because this horizontal that occurs beneath the 37-degree angle is really 6 feet off the ground. So if we add on that extra 6 feet for the total height of the tree, we end up with 54.1 feet.